We're going to finish up the page 287 to 288 problems. I'm going to continue with number 46. And 46 is just asking you to identify domain, range, continuity, all of the terms from what we learned at the beginning of the year. And 46 is a pretty straightforward exponential function, so you should know by now that 3, that's the a value, that's the y-intercept, the initial value. And our base is 2. And so if I was to look at this graph very quickly without a calculator, I would be intercepting the y-axis at 3. And then every one that I go up, I'm doubling. So at 1, I would be at 6. At 2, I would be at 12. So I'm going up over that page there. So at 1, I'm at 6. And at 0, I'm at 3. And if I was to divide it in half, at -1, I'm going to be at 3/2, so 1.5. So you can quickly see what this graph looks like. Okay, so we're going to look at domain. -infinity to infinity. All exponential functions have -infinity to infinity for their domain. Range. I have a lower bound here, so my range is not including 0 to infinity. All of the y values above 0 are in my range. This function is increasing always because if I go from left to right, I'm always going up. So it's increasing from -infinity to infinity, and there is no decreasing interval. For symmetry, there's no symmetry. Exponentials don't have symmetry. Boundedness, it is bounded below by the y = 1 line. Extrema, there's no extrema. It never reaches a lowest point and never reaches a highest point. Asymptotes, y = 0 is a horizontal asymptote. In end behavior, limit as x approaches infinity of the function is infinity. Limit as x approaches -infinity of the function is 0. Okay, 48. I'm going to sketch it for you, and then we can just walk through these very quickly. So we have f of x is equal to 5 times e raised to the -x. So again, I'm going to rewrite that as 5 times 1 over e raised to the +x, because that negative just means I can flip my base over. 1 over e, that base is less than 1, because 1 over e is 1 over 2.7. That's less than 1. And so I know that this is a decay function. My initial value is 5, so I'm going to put my initial value on 0, 5. And then this is going down, so at 1, I would have a point that's 5 divided by e. Whatever that is, it's going to be an irrational number. At -1, I'm going to have a point that's 5 times e. So at -1, I'm up something like 15 or 12 or something. Right, so here's my decay function. Right, so you always want to get your exponent to be +x and check your base. That's how you decide growth or decay. Don't leave it with a negative exponent. Get the exponent to be just 1x and see if your base is greater than or less than 1. Okay, so here's our function. So domain, -infinity to infinity. Range, 0 to infinity. The y values from 0 up are in this. It is decreasing from -infinity to infinity. There is no symmetry. It is bounded below. The horizontal asymptote, y = 0. The limit as x approaches infinity of this function is equal to 0. This is coming at the 0 line, right? The limit as x approaches -infinity of this function is equal to infinity. Okay, number 50 is a logistic function. So let's take a quick look at 50. I'm going to sketch it quick. If you need to do it on your calculator, you can, but you shouldn't really need to do this on your calculator based on the last video I gave you. Okay, so if we do this function, we know that it's going to cross at 6 over 1 plus 2. So if I put f of 0, we get 6 over 1 plus 2 times 1. 6 over 3 is 2. So this logistic function is crossing at 0, 2. And then we're going to have asymptotes. So if I put in positive infinity, 6 over 1 plus 2 times 1 over e raised to the infinity, because I'm going to make this e to the negative x. I'm going to rewrite that as 1 over e to the positive x. And then I can see that base clearly. If I do 1 over e to the infinity, that gets very, very, very small, goes to 0. Right? This goes to 0, and so the limit as x approaches infinity of this function is going to equal 6 over 1 plus 2 to the 0, so 6 over 1 is 6. On the logistic function, this top value, as long as it's a 1 plus something on the bottom, this top value is always going to be one of your asymptotes. So now I know that I'm going up towards there, like that, and then this side here is going to go down towards 0. Okay, and you can plug in limit as x approaches negative infinity of this function is going to equal 6 over 1 plus 2 times e raised to the negative infinity. Go back to that version, put negative, and you get 6 over 1 plus 2 times e to the infinity. E to the infinity is huge, and so the bottom of this goes to infinity. And so when I go towards negative infinity, my lower asymptote is 0. Okay, so I have my end behavior. And now the question is, what is the domain? So the domain of this function, negative infinity to infinity. The range of this function, 0 to 6, not including either. Is there symmetry to this function? So this is not the midpoint between 0 and 6, so the symmetry, the inflection point is over here a little bit, so there is no symmetry. It is bounded. It's bounded above and it's bounded below. It is increasing always. There's no decreasing part of this function. And I believe I got everything. Extrema, there's no extrema because it doesn't actually hit a max or a min. It just has asymptotes. And we did the end behavior because these two are the end behavior. That's how we graphed it. Okay. And then there's 2 more questions that are word problems, and I'll go over those in the next video.